the example with a cylindrical capacitor. Let's say that you've got a metal pipe that has a radius of 6.25 centimeters. And inside this, you have a little smaller thing that has a radius of 1 centimeter. Okay, so that's going to be your B, that's going to be your A. Okay, and so let's say the entire system is 1.35 meters long. And so what happens is that you have this thing and you rub on the outside of it a little bit and transfer charge through static electricity. So let's say that you put a charge of 46.5 nanocoulombs onto it. So the question is, what's the voltage? What is the voltage between the two? Because you've now put charge on it, therefore there's going to be an electric field in there, therefore there's going to be a voltage. Okay, so you've actually just charged it up here without even trying to do anything, and so so now it's going to have a voltage. So the question is, what kind of voltage? Well, we know the capacitance is going to be Q over V, so the voltage is just going to be C times V. Okay. Sorry. The voltage is going to be Q over C. Okay. And so that's all that we have to do there. Okay. So we have to first of all find the capacitance because we know what the charge is. Well, it's a cylindrical capacitor. So the capacitance is 2 pi epsilon naught L over natural log of B over A. So if you plug in those numbers, that comes out to be 4.10 times 10 to the minus 11 farads. Okay, or you'd normally write it 41.0 picofarads, because engineers much prefer writing it that way rather than using the longer form. Okay, so now to find the voltage, then that's just going to be Q over C. So that will be 46.5 nano 10 to the minus 9 coulombs divided by the 41.0 times 10 to the minus 12 farads. So the voltage actually comes out to be about 1130 volts. Okay, now what does this mean? It means that all you had were these two metal tubes, and you just kind of stroked one of them slightly, got not very much charge on there. We're talking, a few dozen nanocoulombs. And so very little charge was transferred, and yet suddenly we got a pretty decent voltage. Now this high voltage is not going to mean that it's going to do a whole lot, but you could get a spark out of it. So you actually could create a spark in this fashion. Yeah, you're not going to power any piece of equipment though, because that's not enough current moving around to do anything. But this is an interesting sort of thing that you can get a pretty high voltage doing this. Now notice that all that we need for a capacitor are two conductors. I mean, I could build a capacitor here. Okay, I could build a capacitor by taking a hammer and laying it next to a wrench, okay, and now we have two conductors. I put charge on one, negative charge on the other. We got electric fields here. We got a capacitor. Okay, that's a terrible capacitor. That thing's going to have just fractions of a picofarad here. So that's not going to be a very good capacitor, but that's all that it takes to build a capacitor. Okay, the capacitance will be defined by the geometry. Well, there's a famous capacitor that's been built in history, and that was Ben Franklin. Ben Franklin flying his kite in a thunderstorm. Okay, and so what happened was, it's a conducting wire that he was using. Now, he wasn't stupid enough to actually hold on to conducting wire. The conducting wire was grounded right here. He was holding on to an insulator there. But what happened was this conducting wire that was conducting electricity, down here, it was hanging a key. So there was a key and was hanging inside of a glass jar that was lined with metal. So we have this glass jar, and the glass jar here, on the outside of it was a metal coating right here. And then on inside, he had his key hanging here, and that's a metal thing inside of another metal. So that means one of them's positive charge, one's going to be negatively charged. We got electric field between the two. Aha, a capacitor. So what he did was he flew this thing, it got charged up, he disconnected it, and now he could take this charged capacitor into the laboratory and use that as a source of electricity. Okay, and this is how he actually demonstrated that lightning and thunderstorms produce electricity, or lightning is actually electricity produced inside thunderstorms. This is all it takes to make a capacitor. So you if you want to make a capacitor, you could just take a wooden box and line the inside of it, with some kind of metal, line the outside of it with some kind of metal, and now you have a capacitor. Okay. And it's not a very good capacitor necessarily, but if you get enough charge on here, you can have a very high voltage. And so this is really all it takes to make a very high powered capacitor.